and this is one among them. Already you must have studied fluid mechanics in fluid mechanics subject in second year, first semester, right? This is almost like a continuation of it, hydraulics and hydraulic machinery. Mostly the principles that you have learned in the subject of hydraulics and hydraulic machinery would be applied, would be implemented here. What are the objectives of this course? Why should we study as a civil engineer this subject? There are two parts. If you look at this subject, there are two parts. Part A, hydraulics. Part B, hydraulic machinery. So in both the parts, you have a term like hydraulic. So what is this? Hydro means water. So something related to water. We already studied fluid mechanics, and we know that water is also one type of fluid. So we'll be dealing with the water, which is the most available fluid on the earth, and we try to look at the mechanics of this water. When it is in static condition, already you have studied in fluid mechanics, fluid statics subject. Okay, when it is in moving, already you have studied with the governing principles of continuity equation, Bernoulli's equation, momentum equation, etc. When the fluid is flowing in a pipe, then how to analyze it? Maybe Darcy-Weisbach equation also you must have studied. So keeping those things in mind, if the water is to be analyzed, then the subject is called hydraulics. In other words, to say it is mechanics of water. It is the mechanics of water. So we study here about the movement of water, maybe in different places like water flowing in a river, water flowing in a canal. This we study. In the earlier case, in fluid mechanics subject, you must have covered the movement of water, flow of water in a pipe, a closed conduit, maybe flow taking place under pressure. Now, in this case, we try to analyze to see that the water flowing in a canal or the water flowing in an open drain, the water flowing in a stream, the water flowing in a river, so on. So the basic difference, if you see, compared to the earlier semester where you have studied the flow through pipes to this is, in the case of flow through a pipe, the entire cross section of the pipe is completely filled with the flowing fluid, maybe water or any other liquid. But in this case, it is not completely filled, but there will be a free surface. There will be a free surface. So in this case, the free surface is something like an interface where the overlying pressure is atmospheric pressure. Overlying pressure is atmospheric pressure. Underlying, the fluid may be moving, set to motion. So there is an interface between the overlying atmosphere and the underlying fluid. Then we say it is a free surface flow, open channel, canal, river, stream. You must observe in all these cases, no, there will be top water surface. There will be a top water surface. But you must not observe any top water surface in the case of pipe flows. In the case of pipe flow, the entire cross section is completely filled with the flowing liquid. But whereas in a canal or in a stream or a river, you must have seen, you must have observed that there is a top water surface which is called the free surface. So this is called free surface flow. This is called
excuse me, sir. Sir, the screen is not visible.
My screen is not visible?
Yes, sir.
Now?
Yes, sir. Now it is visible.
Okay, so I have not changed my screen because just I'm giving a bit of introduction now about the subject first. Okay, so there are two parts. Hydraulics, it is the mechanics of water, where there is a flow of water, maybe in a stream or a river like that, unlike pipes. And this is the part A of our syllabus. It is the mechanics of water. When the water is flowing in a canal, when the water is flowing in a stream, how do we analyze that? Second part is to look at the machines, hydraulic machine. Hydraulic machine is the one which makes use of the hydraulic energy. As we all know, hydraulic energy may be in two forms. Maybe like it may be a kinetic energy or it may be potential energy. It may be a potential energy like elevation energy and datum energy, and the pressure energy. So which makes use of the machine, which makes use of the energy of water, is called hydraulic machine. hydraulic machine. So this is part B. We study both the hydraulics part, that means open channel flows, and the hydraulic machine, which makes use of the energy of water. Energy of water. Okay. So there are two parts in this subject, like hydraulics and hydraulic machinery. What are the objectives of this course? As a civil engineer, why should we study about this course? This is the immediate question that you may be getting. You are a civil engineer. You will be dealing with several activities like construction of a building and maintenance of the building, construction of a road, dam, canal, everything. So one of the basic branches of this engineering in civil engineering is irrigation engineering, which means that you are supplying water for raising the crops, maybe to the farmers. How do you supply water? The water is supplied through the canals. Water may be available in the reservoir. By constructing a dam across a river, the water may be stored, and this stored water may be supplied. This stored water may be supplied through a canal to the irrigation field. So if you are an irrigation engineer, you need to understand about the entire mechanics of this open channel flow, how the water flows from the place of availability to the place of requirement, irrigation field. So this is, as a civil engineer, we have a lot of social responsibility also, to see that all the farmers are comfortable, to see that all the farmers get the water as and when required to raise their crops. So this is the responsibility of the civil engineer, responsibility of a irrigation engineer in particular. So in civil engineering, this is one of the major or core disciplines in civil engineering, supply of water for irrigation for raising the crops. So this would be taken up by the irrigation department, like R&D department, roads and buildings, and municipal health, public health department, then transportation, and then the other part is irrigation. So these are all the major disciplines of the civil engineering, wherein you are presently in the irrigation field. So to supply water from the reservoir to the irrigation field, we need to look at the canal. Canal is a channel. It is an open channel where you have a free surface flow. That is how a civil engineer is required to study about this subject, hydraulics and hydraulic machinery. The objectives of this course is, we need to understand various types of open channels. What is this channel or a canal? Loosely we say channel and canal are same, but in particular there will be a little difference. But for the moment, please try to understand that flow of water with a top water surface which is exposed to atmosphere is a canal or a channel also. Loosely we use both as the synonyms, but there is a slight difference. For the present, you feel like channel is a canal. So all of you must already seen the canals where the water flows. So we need to understand what are the various types of these canals or open channels, and to study what are the various types of flows in channels. Already in pipe flows, you have seen different types of channels, different types of flows in your earlier semester, like steady flow, unsteady flow, uniform flow, non-uniform flow, laminar flow, turbulent flow. Have you studied about this? In fluid mechanics, in your first semester, in the similar lines, when the flow is taking place in a channel, how do we classify these flows? This is also another objective of our subject. Next, to analyze the uniform, non-uniform flows, critical flows in the open channel. So once we understand about what is the uniform flow, what is the non-uniform flow, what is the critical flow, then what are the governing principles? Whether a Bernoulli's equation can be applied to analyze, whether a momentum equation is also required to analyze, or continuity equation simply is sufficient to analyze this. Okay, so three basic equations, like continuity equation, which is derived based on the law of conservation of mass, Bernoulli's equation derived based on the law of conservation of energy, and then impulse momentum principle or momentum equation. So these are the three equations. Either the combination of these equations or the standalone equations may be used for analyzing different types of flows in the open channels. Next is methods of solving the fluid flow problems using dimensional analysis technique. This is another objective of our course. What is this dimension? We know very well about the dimensions and units. You must have studied in physics also. So we are representing any of the quantity with a specific unit and with a specific dimension, like in a standard mass, length, time, MLT system. If you take, there are three fundamental quantities, primary quantities. Any quantity can be derived with an expression in terms of the fundamental quantity, like either mass, length, time. Simply to say that, how do you represent velocity? Velocity is distance by time, LT to the power -1. So this is the dimensional formula for velocity. So any quantity can be provided with a dimensional formula, can be derived with a dimensional formula in terms of the primary quantities, mass, length, and time, or in terms of the fundamental quantities, mass, length, and time. The advantage of this mathematical technique is we can solve many fluid flow problems. We can solve many fluid flow problems. Of course, a standard conventional method also may be used for solving the problems. Just like if we take flow through an orifice, which you must already well versed with the subject in fluid mechanics, with the topic in fluid mechanics, flow of water through an orifice. What is orifice? A small opening provided by the side of a tank. So if you just allowing the water to flow, a jet of water comes out of through this orifice into the atmosphere. How do you reduce the discharge? How do you derive the equation for the discharge? You may be applying the Barnow's equation, you may be applying the continuity, you may be applying the momentum equation, and finally you may be arriving at the equation, the discharge through the orifice Q would be equal to CD into small a into square root of 2GH. CD, the quotient of discharge, A cross-sectional area of the orifice opening, and H is the head available, constant head available. So these are all the parameters based on which you would be deriving the equation for the discharge through a small orifice, okay? But there may be certain complicated phenomena where it may not be that easy to make use and apply the simple principles of the continuity equation, Bernoulli's equation, and the momentum equation to analyze the fluid flow problems. Sometimes they are very complex. So a mathematical technique by name dimensional analysis is an effective tool for getting the solution for many of the fluid flow problems, including the fluid flow problem, what I told, like flow through an orifice, flow through a venturimeter, flow through a rectangular notch, flow through a CPLT weir. For all these, a mathematical technique, dimensional analysis technique also can be alternatively used for getting the solution for many of the fluid flow problems. So one of the objectives is how to solve the fluid flow problems, making use of these dimensional analysis techniques. There are two basic techniques, like Rayleigh's technique and Buckingham Pi theorem. So making use of these two techniques, will be able to solve the problems of the fluid flow as an alternative solution for the conventional solution of the fluid flow problems. So we'll be making use of the dimensions of various variables involved in the phenomena, like Q, the discharge, A, the cross-sectional area, which is equal to pi by 4 d square, cross-sectional area of the orifice, pi by 4 d square, d is the diameter, G, acceleration, H is the head. So these are all the variables involved in the phenomena. So we try to arrive at the dimensions or the dimensional formulae for these dependent and independent variables involved, and try to make use of one of the techniques, dimensional analysis techniques, to get the solution for the fluid flow problems. So this is another objective of our hydraulics and hydraulic machinery subject. Next is about the modal studies and the importance of these modal studies. All of you must have been well versed with the term modal. What is modal? Modal is a small scale replica of the actual structure. Maybe actual structure is a prototype, and model is something like which may be prepared in the laboratory. A small model, a small structure. If you would like to construct a dam in the laboratory, is it possible? No, we construct a model for a dam in the laboratory. So this is what is a model. It is a small scale replica of the actual structure. Actual dam may be 100 meters height, 200 meters long. Such a dam, you would be modeling it in the laboratory for a small physical dimension, maybe 1 meter height and 2 meters length in the laboratory. This is what is the model, small scale replica of the actual structure. So the importance of this model would be studied because we are all the civil engineers, you know very well. a huge amount in the terms of hundreds, thousands of crores is pumped in for any other project. You see, recently, class-1 project, when it is put to thousands of crores has been spent, thousands of crores. So after spending all that, if you say that, no, the class-1 project, I should have changed these dimensions. Instead of providing a dam of 100 meters, I should have provided a dam of 99 meters only. Is it really possible to decrease or to increase the dimensions of any of the hydraulic structures? Is not possible. It is almost impossible. Also, it involves a lot of cost also. So that is the reason why, as a civil engineer, we would like to see the performance of any of the structure before it is actually executed in the field. As a civil engineer, we would like to see the performance of any of the structure which is before it is actually executed in the field. Before a dam is constructed, we would like to see construct a small dam in the laboratory. Verify whether it is functioning correctly or not. Verify whether the performance is the best for this dam or not. If it is not, what you have to do? This 1 meter height in the laboratory may be changed to 1.1 meter or 0.9 meter. Again do it. Conduct several tests on it. Arrive at the stability, arrive at the performance. If everything is good, you transfer these dimensions to the actual dam in the field. So this is what a civil engineer usually does. That is how, for the civil engineering structures, models are very, very important. For any of the actual structure, before it is going to be actually executed in the field, we construct a small scale replica known as the model, and this will be constructed in the field, in the laboratory, and arrive at the performance by changing several dimensions and conducting various tests on this. And if the model is functioning well, transfer these parameters, transfer these dimensions to the actual structures. That is how a model is very, very important for a civil engineer. So we see how the models would be constructed in the laboratory. What are the studies that are to be taken up for constructing a model? What type of laws, principles can be applied for preparing a model in the laboratory? And its importance would be studied. And this is also one of the course objectives for this subject. Hydraulics and hydraulic machinery. So till that part, all these objectives would be covered in the first part of hydraulics. Then we'll be moving into the second part, hydraulic machinery, or a turbo machine, or a hydraulic machine is the one which makes use of the energy of water. So what are the principles involved in making use of the energy of water? In a very simple terms to say, turbine. You must have heard of a hydraulic turbine. So the purpose of turbine is to generate mechanical energy or to generate power. So this mechanical energy in turn will be used for generating the electric power. Generating the electric power. Such power is called hydroelectric energy or hydroelectric power. You must have seen several hydroelectric power stations like at Nagarjuna Sagar, at Srisailam, wherever a dam is constructed. No, it is usual practice that we go for, to the extent possible, we go for constructing a power station also, hydel station. We call it as a hydel station, hydroelectric power station. So the main component that is used there is a turbine. It is a turbine. So it makes use of the energy of water, hydraulic energy. That is why it is called hydraulic machine. So what are the principles involved in working of these turbo machines or hydraulic machines? And this is also one of the objectives. So to study more about this hydraulic machine, what are the principles and how they work, what are the various types of turbines, similarly pumps. There are two different types of hydraulic machines which are covered in this subject. One is the turbines and the other is the pumps. What is a turbine? What is a pump? Turbine which makes use of the hydraulic energy and gets converted into mechanical energy. Once the mechanical energy is developed with the help of a turbine, this mechanical energy in turn is used to generate the electric power by connecting to an electric generator. This is the main purpose of a turbine. On the other hand, pump will perform a reverse operation. What is the reverse operation? In the case of a turbine, hydraulic energy is converted into mechanical energy and then electrical. Whereas a pump makes use of the electrical energy with the help of a motor, gets converted into mechanical energy, and this mechanical energy will be used in imparting the more and more hydraulic energy to the flowing liquid. That means it provides more hydraulic energy to the liquid. Whereas a turbine utilizes the hydraulic energy of water, whereas it imparts more and more hydraulic energy to the water. Pump provides more and more hydraulic energy to the water, which in turn will be used. If a liquid is imparted with more hydraulic energy, that means it may be a pressure energy, the water can be lifted to higher levels. The liquid can be lifted to higher levels. So that is how a pump will be used. In a very simple sense, to understand, in your apartment or in your house, you may be getting water on the roof, maybe overhead tank. You must order the overhead tank. So you may be getting water into the overhead tank. How do you get the water there? You are using a pump to lift the water, maybe from the borewell or maybe from the sump which is available in your home, to lift this water and get collected directly at your overhead tank. So this is what a pump performs. So pump is another hydraulic machine which is used to lift the liquid from low energy levels to higher energy levels. So these are both the hydraulic machines like turbines and pumps. And we study about both their principles, working, various types, hydraulic designs, everything will be taken up in this topic. Next is modal analysis of turbines and pumps. We have already seen about the modal study for any of the irrigation structure. In the similar way, we take up the modal analysis of the various types of turbines and pumps. To be very clear, any civil engineer would like to see the performance of any of the structure before it is actually executed or constructed in the field. That is how we prepare a small scale model in the laboratory and conduct various tests in the laboratory and verify whether this is working perfectly or not. And if it is found working perfectly, then the same thing will be executed in the field. Okay, so these are all the objectives of our course Hydraulics and Hydraulic Machinery. What are the course outcomes? The course outcomes are the students are expected to gain knowledge in the open channel flow and its analysis. So by the end of the course, it is expected that you should have thorough knowledge about the open channel flows. You should understand about what are the various types of flows, like uniform flow, non-uniform flow, steady, unsteady flow, and then analyzing various types of flows like critical, subcritical, supercritical flows. Everything must be analyzed. Then you are expected to solve the problems of the fluid flow using any technique of dimensional formula. So Raleigh's method, Buckingham method, you should be able to use and solve the problems of the fluid flow. Then the students are expected to design the model of a hydraulic structure for any prototype using these similarity laws. We may be using several similarity laws or principles. By making use of these principles, you should be able to design a model in the laboratory. Actual dam, measure the length of the dam, measure the height of the dam, find out what is the velocity of flow into the dam. Come back to the laboratory, prepare a model for that Nagarjuna Sagar dam. The height of the model in the laboratory must be this much. And the length of the model dam must be this much. And you perform various tests for this. So this is what designing the model for any of the hydraulic structure. Need not necessarily be a dam. It can be anything. It could be a weir. It could be a barrage. It could be a dam. It could be a turbine. For any of the actual structure, you should be able to provide a model. Next, select the specific type of turbine. Also should be able to carry out the hydraulic design for a different site conditions. Different types of turbines are there, like impulse type turbine, tangential flow turbines, radial flow turbines, axial flow turbines, mixed flow turbines. Okay, so for these types of turbines, you should be able to pick up the correct type of turbine and carry out the design. Then design a pump, select a suitable pump for a given condition. So if your house is maybe a simple independent house, what should be the capacity of the pump? You should be able to tell. You should be able to tell to your parents, saying that ours is a simple G+1 independent house. So this much capacity of the pump is sufficient. Maybe 1 kilowatt, 1.5 kilowatt, or 1 HP, 1.5 HP. Capacity of the pump must be sufficient to lift the water to our tank. Or I'm staying in an apartment. It is a high-rise building of 30 floors. I'm staying in, say, 23rd floor. Then what should be the capacity of the pump to supply water to all my 30 stories, 30 floor apartment? What should be the capacity? What should be the size of the pump? How many such pumps are required? How to fix all these parameters? So this is what is called the design of a pump and selecting a suitable type of a pump for a given condition. So these are all the course outcomes. So by the end of this course, you are expected to do all these things. This is a course outcome. So to study about this subject, hydraulics and hydraulic machinery, the prerequisites are you must have completed fluid mechanics subject. So you should know thoroughly about the simple fluid flow principles, like fluid kinematics principles, types of flows, then continuity equation for one-dimensional, two-dimensional, three-dimensional flows, then fluid kinetics, then Bernoulli's equation, momentum equation, flow through the pipe, and analysis. Everything you must have studied in your first semester, and this is the prerequisite. You should have a thorough knowledge of all this. Don't worry, because your exams are not yet over. Even if you have not completed the analysis, I mean, you have not completed the complete preparation of your fluid mechanics, I'm sure you will be able to go through these at your free time, which may be useful for your first semester examinations, as well as for understanding our subject hydraulics and hydraulic machinery. Okay, so for the sake of the convenience, the entire subject is divided into 5 units. One is the open channel hydraulics, then the second unit titled dimensional analysis and about the turbo machines and principles and basics, hydraulic turbines, pumps. Now all the 5 parts are very clear to you now. Open channel hydraulics, dimensional analysis techniques, and turbo machine principles, turbines and pumps. So these are all the 5 units. The first unit deals with the open channel flow. So we need to understand about what are the various types of flows, various types of channels, and how the velocity gets distributed in an open channel flow. You see in the figure, this is an open channel flow. It's carrying water. Are you able to observe this? So you have the left bank and the right bank and bed of the canal, and the water is flowing in this. The water is flowing in this. So how the velocity gets distributed in this open channel flow, and what is the energy equation, Bernoulli's equation, what is the momentum equation that is applicable here, and what is the energy correction factor you need to apply alpha, what is the momentum correction factor beta, why should we apply this would be known, because we have already derived this energy equation and the momentum equation by making certain assumptions in our fluid mechanics subject. We must have made several assumptions while deriving the Bernoulli's equation, while deriving the momentum equation. For the sake of our mathematical convenience in the analysis, we make certain assumptions. Can you recollect what are the assumptions that you have made? The flow is steady. The flow is uniform. Okay. The fluid is ideal. The flow is one-dimensional. All these types of assumptions we must have made while deriving the Bernoulli's equation, while deriving the momentum equation. When you make certain assumptions, there are 2 types of understandings that are required. When you make any assumption for deriving an equation, you are first of all very comfortable because you are assuming, so you don't need to enter into a lot of complexity involved in the analysis. You are coming out so simply with a certain result. This is one understanding required for you about making the assumptions in the analysis of a problem. Secondly, if these assumptions are not justifiable assumptions, they are not justifiable assumptions, naturally the result that you obtain from the analysis of such problems may not be reflecting your actual situation. May not be reflecting your actual situation. What does it mean? Meaning that you should be able to make an assumption which is nearly justifiable. If I say that from here I want to travel to Delhi, You have several paths to travel to Delhi. Maybe by train, maybe by bus, or maybe by road with your own car, maybe by flight, and so on. Several ways that you can reach Delhi from Hyderabad. And you need to make an assumption with regard to this. You are traveling by car. Assume that you are reaching Delhi in 20 hours, if I say. This assumption appeared to be nearly reasonable because reaching Delhi may be about 1500 kilometers and you are expecting, you are assuming to reach in 20 hours. So the distance required to be covered per hour is about 70-75 kilometers. You need to take a break and you need to reach there. 20 hours is okay, acceptable or justifiable assumption. If I say that I want to go by car to Delhi in 2 hours, I repeat, I am assuming that I reach Delhi from Hyderabad by car in 2 hours. This is not a justifiable assumption. So whenever you have to make an assumption, it should be a justifiable assumption. If I assume that I'm reaching Delhi from Hyderabad in 20 hours, maybe slightly this way, that way is justifiable. But if I say that, if I assume that I'm reaching Delhi in 2 hours by car, not justifiable assumption. So this is how there will be certain assumptions, and you must have carried out the analysis while deriving the Bernoulli's equation, while deriving the momentum equation. You must have made certain justifiable assumptions. The fluid is ideal. The flow is steady. The flow is uniform. The flow is one-dimensional. Like this, certain assumptions you must have made. So what is the justification for this? To be frank, if you make an assumption that the fluid is ideal, what is ideal fluid? Ideal fluid by definition is the one which does not possess any viscosity. There is no resistance to the motion. Can you find such ideal fluid in nature? No.
No.
Any fluid, including air, including water, which are having very low values of viscosity, but they offer resistance to the motion. That is the reason why Darcy-Weisbach equation, HF is equal to FLV square by 2GD. Why it has come? The loss of head. There will be loss of energy as the water is flowing in a pipe, and this loss of energy is accounted for to overcome the resistance that is offered by the pipe boundaries. Okay, so you know very well that there is no ideal fluid available in nature, but still you make an assumption that the fluid is ideal and try to proceed. Is the assumption justifiable? We know it is not justifiable because we don't have any fluid without offering resistance. Sometimes the resistance, the viscosity may be more for some fluids, the viscosity may be very low for some fluids. However, there will be resistance to the fluid. However small the value of the viscosity is for a given fluid, there will be resistance, including air. You must observe when you are driving, when you are traveling in a car, when you are driving in a two-wheeler, it flows, it blows over your surface. It offers resistance for the motion of your object. Let it be a car, four-wheeler, let it be a two-wheeler. It offers resistance. So to overcome this resistance, what you have to do? You have to give more acceleration. If you are giving more and more acceleration there, more fluid is consumed, more oil is consumed. So to overcome the resistance, you are spending more energy. You are spending more energy. The same is the case when the water is flowing in a pipe, loss of energy due to friction, Darcy-Weisbach equation is there. So my point here to stress upon is that you should make a justifiable assumption. If you are not able to make a justifiable assumption saying that I can reach Delhi in 2 hours by car, by road, it is not justifiable. Sometimes it will become, it will have a serious repercussions in the result that you obtain, which may not be directly matching with the field results, However, we are making an assumption saying that the fluid is ideal, the flow is one-dimensional, the flow is steady, the flow is uniform, and so on. So what we try to do is, initially we make such a type of very serious assumptions, analyze the fluid flow problem, get some solution, try to understand the impact of your assumption on this solution. This is what we do as a hydraulic engineer. We assume that the fluid is ideal. If the fluid were to be real, what would be the change in your final equation? So we start from the ideal fluid flow theory, move towards the real fluid flow theory. Our goal is to see that the solution that you obtain exactly matches with the practical results. Exactly matches with the practical results. But we make an assumption, however serious it is, that the fluid is ideal, and we have carried out in that assumption, and we made the ideal fluid flow, and we developed the ideal fluid flow theory. Later, we try to move towards the real fluid flow, which directly matches, the results of which directly matches with the field results experimentation. So in this process, you made an assumption that the fluid is ideal, but we know very well water is not an ideal fluid. Water is a real fluid. So when the water is flowing in a pipe, or when the water is flowing in a canal, there will be resistance to the flow. So if this resistance is also taken, then we have to incorporate a correction factor, which is known as a kinetic energy correction factor. Similarly, for the momentum equation, we have momentum correction factor, alpha and beta. So how do we derive the equations for alpha? How do we derive the equation for beta? And how to make use of our equation, which is more nearer to the practicality. So the velocity distribution, energy, momentum, correction factor. Similarly, what are the governing equations for analyzing the uniform flow in open channels? Maybe Chezy's formula, Manning's formula, Bayesian's formula, etc. Just like you have Darcy-Weisbach formula, Darcy-Weisbach equation in the case of pipe flows. Here are these equations like Chezy's equation, Manning's equation, Bayesian's, and so on. And then, of course, the relative merit of these equations also will be looked into. Then, most economical channel sections, which are also called hydraulically efficient sections, when the water is being carried, how efficiently the channel is carrying the water. So this is what is hydraulic efficient, also called most economical section. So how do we define these? What are the conditions for the most economical section, and how to get the most economical section dimensions, maybe for a rectangular channel, maybe for a trapezoidal channel, maybe for a circular channel, triangular channel. We try to see all that. Okay, rectangular, triangular, trapezoidal, different channel sections will be studied. Continuation of that, flow of water, maybe uniform, non-uniform, critical flow also, the flow taking place, critical flow. Then we define a term like specific energy corresponding to the critical condition, the depth corresponding to which is called the critical depth, and how to compute the critical depth in the channels, and various types of flows like critical, subcritical, and supercritical flows, and conditions for the maximum discharge and the minimum value of the specific energy when the flow is critical. Similarly, non-uniform flows and the governing equation for the non-uniform flow, like dynamic equation. I was telling you, like we made an assumption that the flow is uniform. But if you see the real practice, in actual practice, the flow may not be uniform. So if it is a non-uniform, then what is the dynamic equation which will be governing the non-uniform flow, one type of which is called the gradually varied flow. Sometimes it may be rapidly varied flow also. And accordingly, the various types of slopes and surface profiles and methods that are used for computing the surface profiles. Then formation of hydraulic jump and how the energy gets dissipated in a hydraulic jump. This is a simple picture of hydraulic jump. So when the water is being let off, there may be formation of the jump where there is a change of state from supercritical to the subcritical state, and hence it is called the hydraulic jump, which is a category of a rapidly varied flow. In the second unit, we discuss about the dimensional analysis. We have seen there are two basic methods of the dimensional analysis: Rayleigh's method, Buckingham pi theorem, and we study about the hydraulic models. We look at various similarity laws like geometric similarity, kinematic similarity, and a dynamic similarity, and how these similarities can be applied and dimensionless numbers can be developed for preparing the models and analyzing the model versus prototype and prototype versus model relations. Distorted models, non-distorted models. In third unit, we study about the basics of the hydraulic machines or turbo machines. A small picture is given here. Like this is the model of a turbine. The model of a turbine. So this turbine may be directly housed in a casing, but here the shape, how it is showing outside is shown here. So there are several buckets, also called blades, which are provided on the periphery of this wheel. So this is a simple example of a hydraulic machine, a hydraulic turbine, specific example of a Pelton wheel. Pelton wheel, this is called Pelton wheel. Okay, so what are the conditions, whether the entire plate or a flat plate or a curved vane is stationary or whether it is moving, then how the hydrodynamic force would be exerting. We have studied in fluid mechanics about the hydrostatic force. What is hydrostatic force? Force exerted by static mass of liquid, static mass of fluid on any of the object, maybe on a vertical surface, maybe on a horizontal surface, maybe on a curved surface. You must have studied in your fluid mechanics first semester. Force exerted by a static mass of fluid, hydrostatic force. Force exerted by a moving liquid is called hydrodynamic force. In order to have a clear distinction between hydrostatic and hydrodynamic force, in the case of a hydrostatic force, the force exerted by static mass of liquid. Maybe you have a overhead water tank, maybe a rectangular tank is there on the top of your home, or maybe an overhead tank which is supplying drinking water, domestic water supply to a colony. It's an overhead tank, maybe circular tank, hinge tank, different types of tank must have been there. In all those conditions, the water is in stationary condition. So water is in static condition. So what type of force that is exerted on the sides and bottom of the tank? It is the hydrostatic force. On the other hand, hydrodynamic force is the one where you have the force exerted when the water, the fluid is in motion, it is moving. Then what is for different conditions, like when it is stationary, when it is moving, whether the surface is a flat surface, whether the surface is inclined, whether the surface is a curved one, we need to estimate the hydrodynamic force for all these conditions. Similarly, if the jet is directly coming and striking at the tip, at the center or at the tip, and corresponding velocity triangles at the inlet and outlet tips, and how to evaluate the work done, and how to evaluate the efficiency and the angular momentum principle. We know the momentum principle. No? It is a moment of momentum, angular momentum principle, and applications to the radial flow will be studied in Unit 3. Unit 4, of course, we have been discussing about the turbines. So what is the hydroelectric power station? What are the various components for a hydroelectric power station? And where it would be provided, like location. What are the various types of turbines? Like Pelton wheel, Francis turbine, Kaplan turbine, propeller turbine, and so on. And what is their working condition, working proportion, and then how the velocity diagrams are drawn, and how to arrive at the efficiency of these type of hydraulic machines, and how to select a different specific type of turbine for different conditions, and how to prepare the modal turbines will be studied in the 4th unit, hydraulic turbines. The 5th unit is about the pumps, centrifugal pump. Different types of pumps may be there, but as per our syllabus, we will be limiting only to one kind of pump, centrifugal pump. How is it different from the other types of pumps? Like this is belonging to the class of a rotordynamic pump. This is belonging to the class of a rotordynamic pump. So we'll be limiting our study to a centrifugal pump. How to install this pump? What are the various details? How do we classify? Various steps work done, and efficiencies and models for these pumps also will be studied. Continuation of that would be hydro power plants, hydroelectric power stations. We know very well at the Srisalem, at Nagarjuna Sagar, we have the power stations. So we'll be generating the hydel power, hydroelectric power, or electric power from the energy of water, called the hydroelectric power. So what are the various terms, definitions? Load factor, utilization factor, capacity factor, and how do we estimate the hydropower potential for a given location? So all this would be studied in the 5th unit, centrifugal pumps. In the 5th unit, centrifugal pumps. So this figure provides you, like you have a dam constructed. So this is all the downstream portion of a dam. On the upstream side, the water is stored. And all these are the spillway portions of the dam where the gates are lifted. The water is allowed to flow through to the downstream portion. You can see here, this is the hydroelectric power station setup. The water, to get this water to this hydroelectric power station, you have the big diameter pipes, large diameter pipes. This is the pipe. So these large diameter pipes are called penstocks. So penstocks are used to supply water from the upstream of the dam, from the reservoir to this hydroelectric power station. Once the power is generated, the same amount of water is discharged into this canal, tail race, what we call tail race, and joins back to the river. So we would be generating the hydroelectric power. In turn, this hydroelectric power so generated would be connected through the transmission lines, and the hydroelectric power is supplied for various purposes, maybe for industrial, maybe for domestic, and so on. Okay, so classification of hydroelectric power plants and defining various terms related to that, and to estimate the hydropower potential. So we have total 5 units connected to this hydraulics and hydraulic machinery subject. So these 5 units, if you see, the first part, hydraulics, is covered in unit number 1 and unit number 2, and the second part, hydraulic machinery, is covered in the remaining 3 units, like basics of turbo machines, hydraulic turbines, and centrifugal pumps. Okay, so this is all about the course objectives, the course outcomes, and the subject content which we are going to discuss in this semester. I